All right, guys, welcome to day 2 of week 5 of biology. So yesterday we did an introduction to chapter 17, which is on arthropods. So today we are breaking down that section. So remember we talked about how there's kingdom Animalia, there's phylum Arthropoda, which we're talking about right now, chapter 17. And then within phylum Arthropoda, there is 3 major sections. So there's Chelicerates, there's crustaceans, and there's insects. So today we're going to be talking about Chelicerates. And I want to just give a friendly reminder that you do have a quiz on chapter 17 that is on Monday, April 27th. And you have a test that is going to be Tuesday, May 5th, and that will be on chapter 17 and chapter 18. Okay, for details on that, I will have a quiz video for you guys, and I will also have a test review video for you. So if you have any questions about that, it will all be ready for you. All right, but for now, let's go ahead and talk about chelicerates. All right, so what makes chelicerates? So these are going to be arthropods that have 1 or 2 body sections. They also have what's called chelicerae. That's how they get their name and partly how they get their category, because they have this claw-like appendage that's going to help them immobilize prey. And you'll see a picture in just a second. We have horseshoe crabs and arachnids in this section. What's crazy is people often put spiders in the category of insects, right? And you know, you're not completely off when you do that because they're all under the phylum of arthropods. But spiders are more closely related to horseshoe crabs than they are to, say a grasshopper. All right, let's talk about their structure and reproduction. So chelicerate structure, so they have 4 pair of walking legs. At least most of them do. 4 pairs means what? A pair is usually 2, right? Actually, a pair is always 2. So 4 times 2 is what? 8. 8. Okay, so think about a spider, 8 legs. Chelicerates are going to have 8 appendages or 8 walking legs. So they have 1 or 2 body sections like we talked about in the slide before. They also have what's called pedipalps. And so these are going to be little appendages that they use to eat with and to sense their environment. Like this, just in case you needed some reference. So if you look at this spider right here, she's a beauty. Okay, sorry. If you look at the spider, you can see what's labeled as the pedipalps. They're like little short arms. And then we have the chelicerate, which is more like a chomper. So it's going to be like a claw-like appendage that's going to be used for immobilizing prey. Remember, we just talked about that. And then look, it has 8 legs. So when we don't count the pedipalp and we don't count the chelicerae, it has 8 walking legs. So that's very important. It has 4 pairs of walking legs. And it's divided into 2 sections. So in this case, spider doesn't have a head. It has a cephalothorax, which cephalo actually is short for head, but its head is combined like with his body. So he has one section, a cephalothorax, and then his second section is going to be an abdomen. Spiders and chelicerates do not have antennas. And they have what's called simple eyes. So they only have 2 to 4 eyes with 1 lens. All right, so chelicerates have unique ways to maintain internal balance or homeostasis with their environment. So they can either have book lungs or book gills. So why would they have book lungs, and then why would some have book gills? Okay, well, if they're on land, they're going to have book lungs. And if they're in the water, like a horseshoe crab, they're going to have book gills. So book lungs and book gills allow air to enter their bodies, and the air goes straight to the tissues without even having to pass the circulatory system. And spiders, they have what's called a spinneret, and that's where they spin their silk from. So you see it's actually on the tip of their abdomen back there. It's called the spinneret. And the silk that they spin is actually from a protein that the spinneret produces. All right, let's talk about chelicerate reproduction. So most aquatic chelicerates are going to reproduce sexually through external fertilization. What that means is that the female is going to lay eggs, and then the male would come along and fertilize those eggs. So it's happening externally. Whereas on the flip side, most terrestrial or land chelicerates are going to reproduce sexually through internal fertilization. So that means that the fertilization actually takes place within the female. Okay, let's talk about one of our oldest friends in the animal kingdom, known as the horseshoe crab. So the horseshoe crab is a chelicerate, and they might not look like much, but they do a lot for us actually. So it's one of the oldest animals, and I think it looks very dinosaurish. And you see that tail that's on the back of them. So a lot of times people are really scared that that's like a stinger of some sort. It's like a barb that they're going to get really injured. And you definitely don't want to get hit with one of those things. But they're actually called telsons, and they help the horseshoe crab flip back over. So if you've ever been to the aquarium and held one in your hands or had one of the volunteers, so there's a picture actually right there of somebody holding it in their hands, you'll notice that, so if this is its body and this is the telson, you'll notice that the telson actually flips like this in order to get it to flip back over. So these guys actually eat worms and clams and algae. And they're kind of scary to look at. You do see them washed up on the beach from time to time, sometimes just their shell, because shorebirds actually eat their insides. But what's really cool is if you look in the top right-hand corner, we actually milk horseshoe crabs. So bear with me. I know that sounds very strange, but when I say milk, I don't mean we're actually getting milk from them. It's called milking horseshoe crabs, but we're actually getting some of their blood. So Brian actually worked for a company called Charles Rivers Laboratories. And what they did is they take horseshoe crabs. They do a bunch of other things, but they take horseshoe crabs, they milk the horseshoe crabs, and they use their blood in order to detect whether or not there's toxins in drugs that they're trying to develop for humans. So this is really important because what it can help with is it limits how much we actually have to test drugs on, say, animals without us knowing firsthand, oh, this is not a good drug or it has certain toxins in it. So really, it's a very humane way to go about drug testing. So that way, when we do have to ultimately do drug testing on mice and dogs and then eventually humans, we've already gone through the step of trying to see the endotoxins that might potentially be in the drugs that we've developed. So the particular company Brian worked for, Charles Rivers, is one of the only companies that does this, and they actually are part of this cool system of they catch the horseshoe crabs, they milk the horseshoe crabs or bleed them, and they actually are able to put them back in the wild, and they tag them so that way they don't keep grabbing the same horseshoe crabs, but they actually will clean off a bunch of barnacles and stuff on the horseshoe crab. If the horseshoe crab has some sort of medical condition that's easy to treat, they're able to treat it and then release it back into the wild. So it's actually a very cool system between nature and man. I believe the way that we should use nature in order to help us, but also not harm the nature in the process. So it's a really cool mutual relationship. The horseshoe crab is helping us out a lot. You'll notice that in that picture in the right-hand corner that their blood is actually blue. The reason for this is the same reason why octopus's blood is blue, and that is because they have copper that makes their blood blue rather than iron that makes our blood red. So very cool, very alien-like. These horseshoe crabs do a lot of good for humanity. So way to be. All right, guys, that is it for chelicerates. I will see you on day 3 as we talk about crustaceans. Hope you all have a great day.